let's try to get as many examples as we can. So I did three methods, if you recall. Euler's method, RK2 Runge-Kutta second order method, and RK4. There is like not a lot of complexity with these methods. It's just a lot of tedious calculations and applying the formula correctly. So here's a problem which we are going to try with all three methods. I want you to be able to do this with pencil and paper in about reasonable time. So you get 60 minutes in the exam, three problems. So this sort of a problem is definitely going to appear like at least one on the module 6. So you have to do this in 20 minutes, okay? So let's start with RK2. I'm assuming that everybody gets the hang of the Euler method on which we did enough examples, okay? For the RK2 method, if you write dy over dt equal to f of t comma y, it goes as y at t plus delta t equal to y of t plus 1 half k1 plus k2 times delta t. That is the RK2 method. Okay. So we are following the version that is equation 25.36. Equation 25.36 in the book, where K1 is the function evaluated at t and y, and K2 is the function evaluated at t plus delta t and y plus K1 delta t. And if you look at the book, they use H for delta t. I like delta t, book uses H. That's the only difference. And here is the analytical solution, which or exact solution with which we will compare our numerical solution. This is a first order ODE, as you can see, and this is the method applied for a first order ODE. But both in the exam coming up, as well as in the quiz, as well as in the take home final, you are going to get a second order ODE or a system of 2 or 3 ODEs. Okay, so it's never going to be just this one equation. Okay. So for this problem, our initial condition is y of 0 equal to 1. For this problem, solve for y of t, given that dy by dt equal to 1 plus 4t times square root of y, and the initial condition is y of 0 equal to 1. So this is how the problem will be stated. Where do you start? Always, for these sort of problems, develop a table and be systematic about this. Don't cut corners. Don't think you can just do it in your head. Skip a step. It will only lead you to mistakes. So start with time. Okay, time. And what is the value of y, the solution at that time, y of t. And then this right hand side function, dy by dt or f of t. So far, right? So what do we know? Always the first step is the initial condition. At time 0, y of 0 is given to be 1. And you don't have to worry about dy by dt or f of ty because you already have the solution at time 0 given t. So this becomes our current, and then we want to advance to the next. At what is our choice of time step? That is, you want to say 0 plus delta t. In our case, we choose delta t equals 0.1. I'm just giving you that value. Choose delta t equals to 0.1. Actually, the book suggests you to do 0.25. Let's do 0.2. Yes, question? Zero plus delta. Okay, then you are trying to compute y of t. That's the whole exercise, right? Y at t plus delta t, or I'll write y at 0.25 equal to y at 0 plus delta t divided by 2 times k1 plus k2. This is your equation. So you need to add two columns. Okay. Remember what is k1? K1 is the function evaluated at t and y. K2 is the function evaluated at t plus delta t and y plus k1 delta t. So to be organized, I'll suggest this. This is your k1. K1 is the function at time and y at these two. So what is the function? This is the function. This is f of t. So you have to evaluate this function at time equal to 0 and y equal to 1. K1 is equal to the function evaluated at time 0 and y1 equal to 1, which would make it 1 plus 4 times 0 times square root of 1, which is 1. With me so far? Santiago? Okay. All right. Then we need K2, which is the function evaluated at t plus delta t and y1 plus k1 delta t. This is K2. I'm just rewriting what I wrote there. So here is a tip to be systematic. You need these two, right? You need these two. And they become arguments to the function f. I would add another column that says t plus delta t and y plus k1 delta t. What is t plus delta t? T is 0. Delta t is 0.25 in this case. So this is 0.25. And I have y, I have k1, I have delta t. So this is, in this case, t plus delta t equals 0 plus 0.25 equal to 0.25, and y1 plus k1 delta t in this case is 1 plus 1 times 0.25, or this is 1.25. 1.25. I'm just asking you to compute the arguments first to this function, keep them safe and secure, then throw them into the function. So that by adding one extra step, you are avoiding a mistake, any mistake. Then I want to compute K2, which is the function evaluated at t plus delta t and y1 plus k1 delta t. So that is like saying K2 is 1 plus what is 4. Wherever time appears, you have to use this as your argument, which is 4 times 0.25 times square root of 1.25. Look at this step, take a minute, tell me if you are saying this looks obvious to me. Does this step make sense to you? The way I've computed this, what have I done here? My K2 is the function evaluated at t plus delta t, which is 0.25, and y1 and y plus k1 delta t, which is 1.25. And my original function is 1 plus 4t times square root of y. So wherever time appears, I have to use this value or 0.25, and wherever y appears, I have to use this value, which is 1.25. That's what I've done here. So this is, can somebody do this calculation and tell me? It is 2 times square root of 1.25. If I were to guess, I would guess this is about 2.2.
2.286.
2.286.
236.
236. 2.236. So 2.236. Are you okay, Tim? So this is what I recommend that you do if your numerical method has K1, K2. Make sure you add separate columns in your table that are K1 and K2 to systematically compute them, and then go on to the next line to update the value of y. So how will you update the value of y? Y at 0.25 is y at 0 plus half delta t k1 plus k2. This is 1 plus half times 0.25 times k1 is 1 plus k2 is 2.236. Can you tell me the value? Two point four point
1.40.
1.40. That's it. Right. Like you said up to 1.40 and then you got bored and then, no, I'm not doing this anymore. Okay, so you have updated successfully the value of the function from time 0 to time 0.25. You have advanced it by 0.25, the solution. Something not here? Okay. So then I want you to then go on to the next time step where you will have plus 0.25. So you are going to time 0.50 and you do that by computing K1 and again computing K2 and using K1 and K2 to get the next value. Can you do this? I'm going to get an Excel sheet out and do this much faster than you to make you feel bad. Anybody has a value for, I mean, you can also tell me the values for what is K1 T plus delta T Z T, that is 0.50, and then K2, Y of 0.50 equal to Y of 0.25 is 1.405 plus half times 0.25 times K1 and K2. So you have to tell me what is K1 and K2. Clock is ticking, it's 19 minutes. Yes? No?
It's just a mind.
K1?
Yes.
2.37? You had that value, didn't you?
Yes.
Then why won't you say it?
It's like
4.24? 1. So 2.371 plus 4.241. And what's the value? Louder please. 2.232. 0.232. Okay, so you still need to be sure that you are doing this right? Which you can do by comparing this value against the exact value given by this function. So y exact for 0.25 would be I have 1.4102. That is the exact value. The exact value is 1.4102 and the exact value at 0.50 is 2.25. 0.25 what? Two five zero zero. So we are about close, not exactly. Obviously, we won't be exactly the same, but we are near the exact value. Okay. So in a typical pencil and paper problem, you could be given an equation that is either first order or second order. Like for example, you could be given an equation. Okay, let me come back to that. Can you do one more time? That is, can you do 0.75 and we'll wrap it up? Do one more calculation at the next time step, 0.75. So I want you to compute at 0.75, which would be y of 0.75 equal to y of 0.50, which is 2.232 plus half times 0.25 delta t times k1 plus k2. So please get me k1 plus k2. K1, K2 at 0.75. After this, we are going to switch to Excel and learn RK4, okay? Anybody has K1, K2? Yeah,
Yeah, for K1, I got 4.481,
4.481,
and then for K2, I got 7.323.
7.323. And what is the value of Y at 0.75?
3.706.
3.706. And the exact value is 3.7539. 3.7539. Which is obtained by substituting time equal to 0.75 in this formula. Are you able to get these three values? Ask yourself. If not, please speak up now. Can you get did you get these three values by yourself? Do you understand the process? We are going to now do the same problem using RK4. Can I move on or should I wait? Okay. Santiago. Okay. Any question, Tim? Okay. All right. So then we need to first learn the RK4 algorithm, which goes like this. Okay. So RK4 is y of t plus delta t is y of t plus delta t over 6 times k1 plus just 1 second. K1 plus 2k2, K1 plus 2k2 plus 2k3 plus k4, okay, where k1 is the function evaluated at t and y, k2 is the function evaluated at t plus delta t over 2, and y plus half k1 delta t, and k3 is the function evaluated again at t plus delta t over 2, and y plus half k2 times delta t, and k4 is the function evaluated at t plus delta t, and y plus k3 times delta t. So you have to evaluate the function 4 times. So you might get a problem both on Tuesday as well as in the take-home final to use Rangikuta method and solve either a first order or second order ODEs. Okay, all options are on the table. and this is equation 25.40. We are done writing up to here. We are going to switch to Excel. I could make a table like this by hand, but as you can see, it will start with K1. We have added K2 for RK2 method. There will be K3 and K4. So it will just be more columns. Can we switch to Excel? Yeah. So on Canvas, I've posted a couple of important files which I hope you would have noticed. One is this module 6 examples, in which I merged all the examples that I could find from previous terms so that you have more examples to go with. Okay. And also I posted this presentation file, which if you actually look at, this was what some of the extra sessions I did last fall. So we used to get together for an hour and we'll write it out in PowerPoint, and you can see each problem we went through in great detail. So you could see the video as well if you want, but this will be a very good kind of guide because we did all the calculations individually and you could check yourself every step of the way. Okay. So I hope you would look at this. Okay, so if you are doing this with me, let's start. This is the final product. I have it ready for you to see. So if you see here, before you begin lookup, here is the step length we are going to use, which I put as 0.5. I can change that. And if you notice, this is the problem which we were doing. dy by dt equals 1 plus 4t times square root of y. And I got the exact solution. And over here on the left, I have the exact solution. Okay. So then if I start my solution process, I need to start with time 0. So this cell right here is my time 0. I put the initial condition. Okay. So at time 0, what is my y value? In the problem, it's given as 1. So this cell here, cell Q3 has the initial condition and also the exact value which I copied from the other column and I put it there. So this is where the problem always starts. Put the initial condition in your table as the first line. Okay. Then you have the second time point for which you increment the time as previous value plus your step length delta t. So if I choose 0.5, that is 0.5. I can change it to 0.25. If everything will automatically update. So if you're going to do this with me now, start here. Make a column. Let me show this to you. So I'm going to say, okay, I'm going to start here. I'm going to copy only the first line. In fact, I shouldn't copy anything because you won't have anything to copy it, right? So I'll say time, and then I'll say y of t times 0, y of t is 1, and my dt is going to be 0.25. This is where you will start. Okay. What did I tell you as the next step? You have to compute K1, K2, K3, K4. So K1, I'll write K1 is the function evaluated at t and y. Okay. which is, what is the function? To remind yourself, f of t comma y is excuse me, 1 plus 4t times square root of y. If you keep forgetting, that's the function you need to calculate, which is 1 plus 4 times whatever time is multiplied by square root of whatever y is. So I'll write, this is step 1, initial condition. Step 2, compute K1. What is step 3? Step 3, compute K2. And to compute K2, you need two things. You need T plus dt over 2. You also need Y plus K1 or half times K1 times dt. So K2 will be calculated using this value of time and Y. Don't put any values directly. Always use it through a formula. Meaning, if I want to do t plus dt over 2, I know it is 0.125, but I won't enter it as 0.125. I will say this is t plus whatever dt is $sign divide by 2. And what is this? This is whatever y is plus half times whatever k1 is times dt, $sign. Okay. And so what is K2? K2 is the function 1 plus 4 times time, whatever time is, multiplied by square root of y, whatever y is. Evaluate the function which depends on time and y using this time and this y. With me so far, Parker? Paul? Okay, you got K1 and K2. I'll make it K1 and K2 as boldface because we need to use them in the next step. Then the fourth step is step 4, K3. We need to get K3, which you will get What is K3? K3 depends on the function. Evaluate that t plus delta t over 2 and y plus half K2 times delta t. So I'll write t plus delta t over 2 and y, or if you want to say one row, y plus half times K2 times dt. So what is this? This is whatever y is plus half times K2 times dt. And K3 is evaluating the function 1 plus 4 times t times square root of y. Okay. Are we together? Step 4. And doing okay? Yeah. Okay, next step is to get K4. So I need step 5, K4. And for that I need t plus delta t and I need y plus K3 times dt. This is just coming from the formula. I just happen to know the formula really well. Otherwise, you will need to use it or look it up on your sheet, the cheat sheet or your textbook. What is t plus dt? Take time and to that add dt with the dollar sign. And then y plus K3 is take y plus K3, you just computed K3 times dt. As you can see, there is a progression to this. You can't get K4 without K3, K3 without K2, K2 without K1. So you have to do it sequentially. Okay. And K4 is 1 plus 4 times 4 times time multiplied by square root of y. Good. Able to follow? Can I put all these together to compute y at the next step? Is everybody ready for that? Lauren, you ready? Shall we put it together? So the time at time t plus delta t, y is y plus 1/6 times delta T multiplied by K1 plus 2 times K2 plus 2 times K3 plus K4. This is the formula. And then there's your value. Implement the formula in the next cell to get the y value at the next time step. And if you had written the formula correctly, from here on there is no more work. Just drag the cells and everything will update itself. Look at that. I have the next set of K1, K2, K3, K4 calculated just by extending the calculation formula from the previous book. That's it. If you set up the formula sheet correctly, your homework and your exam, the take-home final, I bet you can get it done in like 1 hour. It's really simple if you are doing this step correctly. Yeah.
Repeat that again.
If you set up the formula sheet correctly,
Could you show how you got? Did you write it on the board? Only one? Yeah, the one.
this one, yeah, it's below, it's behind. You mean this formula for y?
Yeah.
Right here. Y at the next step, y at the current step, plus 1/6 of delta T multiplied by K1 plus 2K2 plus 2K3 plus K4. That's it. This is why you have to so carefully compute K1, K2, K3, K4 so that you can update it. You got it?
Yeah.
Okay, so now it should make sense when I say in the next row, update the value of y using K1, K2, K3 and K4. All right, so here we have y is 1.410089. And if I go back to this sheet, I can check up what my exact value is. Actually, I can just do that here. What is my y exact? I have a formula. Y exact is right here. 1/4 times t, whatever time is, plus 2 times t squared. No, wait, messing this up. 2t squared, the whole squared, correct. 2t squared, the whole squared. Oh, I'm missing something. T plus 2t squared, the whole square. 2t squared, the whole square. Oops. Oh, plus 2. Plus 2. I forgot the initial condition when I did the integration. Okay. Plus 2. So I should include plus 2. Yeah, there we go. So exact solution is 1.41 and we'll calculate percentage difference, which is 1 minus numerical value divided by exact value times 100. So that's 0.004% or 0.005%. Okay. Okay. Now, if you want to advance the solution, what do? If you have done the work up to here correctly, just copy this and copy it onto the forward cells. So you should start getting the solution. Yeah. So here is your solution for 0.25, 0.5, 0.75, and so on. Okay. This is the easier version. This is just one first order ODE that you have to solve. But the exam problem is going to be solve d squared y over dt squared equal to something. That is the kind of problem you're going to get. Okay, I will most definitely say you are not going to get a first order equation, either in the exam or in the Tuesday's exam or the final. Okay, so what do? That is where we have to go forward. Those who are trying, can you tell me if you are done or if you are like have any questions before we move on? Are you able to get these, Parker? Santiago? Paul? Almost there? There? Almost? Yeah. Yeah. This is hard to read. Here is the screenshot. Oops. So whatever appears in the cell E4, this is the formula. Oh, y exact. Y exact is, I'll write it here. Y exact equal to 1 by 4 times 2 plus t plus 2t squared, the whole square. Can we move on? Like now you are able to do, you should be able to do the same first order ODE using Euler method, RK2 method, which involves computing K1, K2, and RK4 method, which involves computing K1 through K4. You can think of Euler also in the same template. Euler involves only K1, RK2 involves K1, K2, and RK4 involves K1 to K4. So I have provided many examples here, and I strongly suggest that you also look at the PowerPoint file that I posted, which oddly has 77 slides. So I think we did a lot of examples. So again, it's a lot of slides, but it's only like 4 or 5 problems. Okay, so please do that. Good. Okay. So for the exam, here are the type of problems that you could expect. Let's see what I have here. All right. Example 25.7 from the book. We are going to solve. Example 25.7. So this could be on the Tuesday's exam. Solve two simultaneous ODEs. Okay. And when I say solve simultaneously, what do I imply? dy by dt equal to minus 2y plus pi e power minus t, and dz dt equal to minus y z squared. This is the problem. It involves two variables y and z which depend on time, and initial conditions are y of 0 equal to 2 and z of 0 equal to 4. And the book is suggesting a step length of 0.1, delta t equal to 0.1, and solve from t equal to 0 to 0.4. Yeah. So solve simultaneously. That is the keyword. And simultaneously means at each step, at each time step, obtain y and z based on either any method that you choose, either RK2 or RK4. That is, at each step, you have to obtain y and z based on each method together before moving to the next time step. That is, you can't just solve y first and then solve z separately. At each step, you have to get both of them. Okay. So the table for this will look like this. So you'll have time, y of t, z of t. At time 0, y of t is given to be 2, z of t is given to be 4. Okay. And suppose we are using the RK4 method. Okay. We would need K1, K2, K3, and K4 for the y. And then we'll also need K1, K2, K3, and K4 for the z. You can see how this can be complicated. So you would then use these values to write y at the next step is y at the current step plus 1 by 6 delta t, K1 plus 2 K2 plus 2 K3 plus K4, but this is corresponding to the y's, and z at t plus delta t equal to z of t plus 1/6 delta t, K1 plus 2 K2 plus 2 K3 plus K4 corresponding to the z's. Nothing to it, right? You can do this. You have to compute K1, K2, K3, K4, two sets of those at each time step. We'll do one set calculation by hand and then we'll switch to Excel. Okay. So what is K1y? What is K1y? K1y is the function evaluated at t comma y. What is the function? And we have to have two functions. We'll call this fy, and then k1z is the function fz evaluated at t comma z. And this function could depend on y and z. So can this function. That is, you have y appearing here and here. In general, you can write this is f2 of time y and z. This is in general f1 of time y and z. Or we'll call it fy and fz. What is k1y? K1y is the function minus 2y plus phi e power minus t, and you have to evaluate this at time 0, y equal to 2, and z doesn't matter because it doesn't appear, but z is equal to 4, which is like saying this is minus 4 plus 5 equal to 1. K1y is 1. You'll also have to compute K1Z immediately, because when you go to the next step, you will need K1Y, K1Z. So the sequence has to actually, I should have written this K1Y, K1Z, K2Y, K2Z, K3Y, K3Z, K4Y, K4Z. That's how I should have written this. So we'll do these two together. What is K1Z? K1Z is the function minus y times z squared evaluated at time 0, y equal to 2, z equal to 4, which is like saying minus 2 times 4 squared, or this is 16 times 2 minus 32. So K1Z is minus 32. Are we together? Yes. Neil? Okay. Now let's go after K2, K2Y and K2Z. K2Y. K2Y is the function evaluated at t plus delta t over 2, and or the function fy t plus delta t over 2, y plus half k1y times delta t, and z plus half k1z times delta t. That is like saying minus 2y plus phi e power minus t, the function, is evaluated at what is t plus delta t over 2? What is my delta t? What is my choice? I think I said 0.1. Yeah, 0.1. So that is t 0 plus 0.1 divided by 2 or 0.05. And what is this? Y plus half k1y times delta t is 2 plus half times what is k1 y 1 times 0.1. So this is again 2.05 at y equal to 2.05. And z, I need z plus half k1z times delta t, which is 4 plus half times what is k1z minus 32 times delta t, which is 0.1. So this is minus 16 minus 1.6, 4 minus 1.6 is 2.4 or z equal to 2.4. Which if I substitute, I'm going to get minus 2 times 2.05 plus 5 e power minus 0.05. Punch it and tell me, please. And just like you do k to y, please do k to z also. And k to z plus fc of the same arguments t plus delta t over 2 half k1y delta t z plus half k1z. Yep. So kindly compute k to y and k to z. I'll be back in 1 second. So what is k to y? And 6 by 6. You don't have to be so that like a voice you do or you just not sure. 0.6. Either it can be correct or wrong. Look at me. I speak so loudly when I'm even wrong. And K to Z? We'll soon find out, so that's okay. You got something, right? Others? Same thing? Both? See, you're right. Okay, so you got K1 and K2. Now we have to move through K3 and K4. You can see how tedious this can be. Okay, so if you are good up to here, I would like to switch to Excel and implement this problem so that we can maybe even cover one more example. Is everybody getting these two values for K1, sorry, K2Y and K2Z? Good, good. Thank you. Parker. Okay. All right. So now switching to Excel. So let's let's see if I did this problem last year. Maybe not. This is problem 25.7, not on my list. Or maybe it's here. I think no, this is not the one. You can check through here. Maybe that problem we would have tried last year, 25.7, if it's in here or not. Okay, anyway, we'll do it now. So if you're doing via Excel, please start a new sheet. Go through steps 1 through 5. But now you have to do it for two variables, not just one variable. Okay. So this is oops, problem 25.7. Okay. And I have time y of t, z of t. This is always the starting point. Time y of t, z of t. What is time 0, y of t 2, z of t 4? This is initial conditions. So I'll write step 1, initial, or let's call it step 0, just to keep it symmetric. Initial condition. Okay. All right, we have less than 15 minutes, so let's try to speed up. All right, step 1, computing K1Y and K1Z. You have to compute the two of them together. Step 1, compute K1Y and K1Z. So I need t plus dt over 2. Sorry, I don't need anything. I just need to compute this. Step 1, K1Y and K1Z, which is the function evaluated at t and y, ty and z. Okay. So function evaluated at ty and z, which would be minus 2y minus 2 times whatever value of y plus phi exponent of minus t. That is K1y, and K1z is minus the value of y times the value of z squared, minus 32. Something not correct? Sorry? Good, okay. Step 2. Step 2 is to compute K1 or K2y and K2z. Step 2 is to compute K2y and K2z. And since this is Excel, I'm just using some more space to write it out. t plus dt over 2 y plus k1y times dt, sorry, k1y times dt divided by 2 z plus k1z times dt divided by 2. And then I have to compute k2y and k2z. Good so far. What is t plus dt? I have to define what is my dt, which I'll say is 0.1. And t plus dt is time plus dt, lock it, dollar sign, divide by 2. And then y plus half k1y times dt, lock it. And then z plus half k1z times dt, lock it. That's my arguments. And then I'll write minus 2y plus phi exponent of minus t. Yep. That's my k2y. There's your 0.656, which you are all worried about. And here is k2z, which is minus y times z squared, minus 11.808. So we got our two values. And we have 7 minutes. So I hope you won't mind me moving to step 3. Step 3 is to compute k3y and k3z, which is, I still need t plus dt by 2, which I'm going to recycle or reuse, but then y plus half k2y, half k2y times dt, and z plus half k2z times dt. Which is, I have to take my y plus half times k2y, which is here, times my dt, lock it, and then z plus half times k2z times dt, lock it. It would actually help you if you say this in your head while you're doing the problems. Say the formula, don't loudly, but at least within your head, so that you do this. That's how it works for me when I practice things. Okay. And then I want k3z, I'm sorry, k3y and k3z, which is the function minus 2y plus phi exponent of minus t, which I'm sharing with this. And then this is minus y times z squared. So that's my k3 y and k3 z. Are you following the steps, if not exactly the numbers? Okay, so we need k4. That's the remaining step. So step 4 is to get k4y and k4z. For that purpose, I need t plus dt. I need y plus k3y times dt and z plus k3z times dt, and I'll get my k4y, k4z. What is t plus dt? This is my t and this is my dt. Lock it. Y plus k3. What is my y? Y plus k3 times dt. Lock. And then z plus k3z times dt. Lock. And then k4 is the function minus 2y plus phi exponent of minus time, and then this is minus y times z squared. I feel like sometimes I should keep these tests like a timed quiz. That is, your score is proportional to the duration of time you take the exam, something like that, so that you will get some speed. Anywho, what's the next step? Next step is to update y and z, right? Hello? Y plus 1/6 of dt times k1 y plus 2 k2y plus 2 k3y plus k4y. That's my y. And my z is same thing, 4 plus 1/6 of dt times k1z. k1z plus 2 times k2z plus 2 times k3z plus k4z. That's my z. If you did this previous line correctly, line 3, everything is correct. There are no mistakes you made. From here on, it's just dragging everything down. Like copy the formulas to the next cells and you'll get your y and z. I just go here and drag this down. And I have to also drag this. There you go. So here's your solution, y and z as a function of time. Actually, this problem has an exact solution which you can obtain in the exam. That is not the intention. Like, I won't ask you to derive an analytic solution. I'll give it to you. But you have to then get y and z. Okay. In the last minute, I do have, what if you get a second order differential equation? What did I tell you about reducing that to a first order equation? Substitute. So suppose you get d squared y over dt squared equal to a function. Substitute dy by dt equal to z. That's your first equation. Your second equation automatically becomes dz over dt equals the right hand side. And the problem then reduces back to what we saw here. Okay, so this is like, you can get two separate equations or a second order equation which is equivalent to two separate equations. Okay. So for the quiz on, sorry, for the exam on Tuesday, I posted 2 mock exams covering modules 4, 5, and 6. I strongly recommend that you practice similar problems and come prepared. It will be, you can bring 1 sheet of notes, right? And since it's 3 modules, maybe if you want, you can bring up to 3 sheets of notes. That's up to you. But I'll allow 3 sheets, okay? I have the optional final prepared and ready. I will post it the following day so that you can start working on it if you want. The last question I have for you is, do you feel like you want me to have like one more session doing practice problems? Would you think that would help, or do you want it? If you don't want it, if you're good with these examples and the recordings, I'm also good. If you don't want to put additional time in class, that's fine with me. I'm ready to put if you want me to. You're saying yes? Okay.
When would we do that?
We would probably have to squeeze it on either Wednesday or Thursday, but I would prefer Wednesday. Thursday, I know you're studied it, right? Sorry? We'll do like a 1 hour session where we can do more examples related to this topic. And for those who are planning to take the optional final, I can show you like some tips related to the final, because that exam is fully Excel based, the optional final. Do one thing, just send me an email if you're interested. Let me get a head count of how many people are really committed to or wanted to do this. If you need help, just set up a time with me. I can go over examples with you if you want, or anyone for that matter.